Okay, so the intention of this video is to be an introduction to how to use a spreadsheet, and in particular I'm going to be using a spreadsheet to capture data from a video and do an analysis on the rate of change. But the primary purpose of this video is as an introduction to how to use a spreadsheet. Now, a spreadsheet is a very useful tool. The most well-known one would be Microsoft Excel, but I'm going to go ahead and use a free version that's on my Google Drive, and I can do that by just selecting a Google Sheet. When I open the sheet, what you notice is that you immediately notice that this is an array of rectangles, and each rectangle is referred to as a cell. And as I look at each of these cells, you can see that there's a column with a letter of the alphabet, A, B, C, D, and there's these rows numbered 1, 2, 3, 4. And with the column, the letter, and the number, you can see that this is the A1 cell, this is the B1 cell, and this over here is the B2 cell. So the letter and the number is sort of an address to that cell. Now, stored within each cell, you can store one of three things: either a number, such as 1, or a formula, such as taking the number in cell A1 and adding 1 to it to get 2, or I can type in some words and they appear on the spreadsheet. Well, what I want to do now is use a video such as this one. It's sure to get a million views. It's a half a liter of boiling water. And if I switch to this video, it takes a few moments to get going. I turn on the temperature, and you can see there's an ambient temperature of about 60.7 degrees Fahrenheit. And if you give it a moment, there's going to be a click right when the temperature is turned on. So it's at a time signature of 14 seconds. And I want to record the time and the temperature, and then do some calculations based on those. And so since I'm going to be constructing a table, I'm going to start with some words. This will be my time column in seconds. And next to that will be my temperature column in degrees Fahrenheit. And what I'm going to do now is type in a 14 for 14 seconds. And I'll go ahead and you know what? Since the time signature is in minutes and seconds, I think this might be a little easier if I have a minutes column and a seconds column. Okay. So what I'm going to do is since I changed my mind, I'm going to go ahead and insert. Let's see if it might just let me. We'll just insert. Let's see if a column to the left. And now everything else has been moved to the right. So let's have this be time in seconds, and we'll have this be minutes. In fact, I think I'm going to go ahead and add a row above. Let's do it like this. We'll have this be minutes and seconds, and that will be my time. So that's going to be 0 minutes, 14 seconds, and I'm going to go ahead and type in my temperature of 60.7. So this will save me a little bit of time, and what I can do now is go ahead and let's do this. Let's go ahead and switch back to the video, and if I press the right arrow, it automatically advances the video by 5 seconds, so I'm at 19 seconds now. And what I see on the reading is 60.8 degrees. So switching back, 60.8, and that corresponds to 19 seconds. Switching back again, I press the right arrow, and it looks like we're still at 60.8. So although the electricity is flowing, not enough heat has entered into the water to make a measurable difference. Now, at each step along the way, you can see that the numbers in my seconds column are very predictable because it keeps going up by 5 seconds. So in order to save a little bit of time, I'm going to show you an example of a formula. And whenever you want to enter a formula into a cell, you have to begin by typing in an equal sign. So there it is. And that's how the spreadsheet knows that I'm going to be giving instructions for a formula. Now what I want to do is I'm going to tell it to take the number that's in the B5 cell, the number 24, and I'm going to add 5 to it. So I'm not going to type in 24, but rather I'm going to type in B5. Now if I press enter now, what you see is a 24, but when I select the cell, the formula says it actually is B5. And if I edit the formula, I can put a +5. And now when I press enter, it did the math, and now the formula has computed the 29. Now the reason why that's a good idea is because when I copy and paste, it's just going to do this with relative referencing. So if I was to copy, go down, and then paste, right? Okay, good, thanks, I understand that. There's shortcuts. So I get a 34, and notice that the cell, although I copied the formula B5 + 5, but when I pasted it, it automatically turned the B5 into a B6. And so if I was to keep copy and paste, 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 you can see that at each step along the way, each time I pasted, the formula changed with it. And that's going to save you a lot of time, because now I can even select a whole bunch of cells and paste, and everything is done automatically. All right, so let me go back into this. I think in the post production, I'll probably speed through this next step, but what I want to do now is start recording every 5 seconds of this 10-minute video. So this is going to end up being a lot of data here. So when I get to 29, we're going to have a 60.8 and 15.9. Okay, so there appears to be a glitch in the video feed. I'm just going to type in, use this as a chance to type in glitch, since I don't have a clear picture of what's going on, and I think that'll work just fine. We'll kind of continue on. This is going to end up being a, oops. So what I'm doing is I'm just copying the formula, and since the number is bigger than 60 seconds, this is a good time for me to increment the time, and we'll just make this to be 4. That's 2 minutes and 4 seconds. Notice all the formulas after that updated, and this will be, I think this will work just fine up to this point, when I'll have a 4 again, and that will be a 3. But since there's something important happening here, I'm going to say that at this point, something important happened. I'm going to go ahead and use some of the formatting that's available to me to do that. At the top, I have some formatting options. I'm going to go ahead and say, I'm going to color this cell red. This means that this is when the temperature stopped. And I'll go ahead and go back up to here and just say this is when the heat was turned on. And by doing that, I can now see I have some indicators, some useful indicators to tell me when the heat turned on and when the heat turned off. .8 and 195.5, and that's the end of the video. At least that's the end of the YouTube video from which I'm extracting this data. And so now with these numbers, what I can now do is create a rate, an average rate of change. So I can really understand like at what clearly the temperature is going up, but I can look at the rate at which the temperature is going up and more interestingly, the rate at which the rate is changing. So what I'm going to do is I'm going to put in the average rate of change over the first 5 seconds. What I'm going to do is I'm going to enter in a formula. Begin with an equal sign. Now what I want to do is I want to see how much did the temperature go up by. I'm going to take the final temperature minus the initial temperature. I'm going to take the number from the C4 cell, and as a shortcut I could just click on the cell and the spreadsheet automatically puts in a C4. I'm going to type in a minus. I'll click on the C3 cell. And if I press enter now, what you see is the difference between those two. You can do that in your head, but this will be done. This will save time to do all these calculations very quickly. Now I'm going to go back and I'm going to edit this formula a little bit more. What I really want to do is I want to take the average rate of change. So I'm going to put an open parenthesis because I want to subtract before dividing by the amount of time it took for the temperature to go up by that much. That's 19 minus 14. I'm going to put an open parenthesis, and assuming that 19 minus 14 is too hard for me to do in my head, click on the B4 cell, minus the number that's in the B3 cell, close parentheses. And what I can see now is that over the first 5 seconds, the temperature was going up at a rate of 0.02 degrees per second. Now, as I copy and paste, as you can see, the formula automatically changed so that now I'm taking the number from the C5 cell minus the number in the C4 cell. And so this is another example of relative referencing. The numbers I'm dividing by also changed. But the thing to notice is that because the temperature didn't actually change right there, we're going to get a 0. But as I copy and then paste all the way down the line, you can see how each of these numbers are being calculated one by one. Now it is interesting to note that at this point there's an error showing up. It says value. And the reason why makes sense if you think about it. If you click on the formula, it's literally taking this word glitch minus 115.9, and that's not computable. And that's why it's giving us an error. So this would be a good reason to just delete the formula in that case. But up until that point, I can see that the rate at which the water is heating up is very slow at first, but then that rate starts to increase and seems to level out after a while. All right, well, continuing on, I want to keep doing these computations, so I'm going to copy the formula here and paste it here so I can continue looking at the rate at which the temperature is changing. And at this point, as I copy, I'm using a shortcut here. You'll notice that what I did there is at the lower right hand corner of the cell there's this little box. In this box, if I let the mouse hover above that corner, I can click and drag. And that's going to be a shortcut for the copy and paste. And that's a pretty useful idea. And eventually you get to the point where the time was shut off. And I'm sorry, when the electricity was shut off. And even though the electricity was shut off, you can see how the temperature continued to go up, but eventually we hit a negative number. And the negative number, if you think about it, makes sense because at that point, the final temperature was, let's see here, what am I doing? Yeah. Okay, I have to back up a step. So what's happening here is, at each step I'm subtracting these numbers, but right here, because I'm using minutes, I'm getting some goofy numbers periodically. So I need to fix that. So what I'm going to do is I'm going to go ahead and just come back into here. For now, just do a simple solution and just type in 5, since each step it was increasing by 5, and paste that. Okay, that fixes that. All right, so anyway, continuing on, what we have here is some more data. And as you can see that when the electricity is shut off, the temperature does seem to kind of taper off a bit. And then it eventually starts to decrease. And whenever the temperature starts to decrease, you can see it with a negative number. So there's a negative rate of change. And that happens whenever the final is smaller than the initial, because you're taking a small number minus a big number. So it's safe to say that whenever the rate of change is negative, that means the temperature is going down. Now in this final cell, it doesn't really make sense to keep that number. After all, it's taking a blank minus 195.5, and the spreadsheet's going to interpret a blank as a 0. So we don't need that number. So this is kind of an introduction to, one, how to use a spreadsheet and to use formulas to save some time and to be able to do quick analysis based on these numbers. And I think we can go ahead and use this. In fact, I think you know what I can do right here? I'm going to add one more formula. I don't want to lose some useful information. What I can see here is I'll do a special formula. This is just going to be this number minus that number. And how long did it take for the temperature to change by that much? It took that long. Now, of course, that's 10 seconds. But what's nice about that is that it allows me to sort of, not lose too much information. And it's still an average rate of change. It's still, the units are still in degrees per second, but it's averaged out over 10 seconds instead of 5 seconds. Anyway, so this will be, hopefully this is something that you can use as a tool to speed up some lengthy computations. It doesn't save you much time, in recording the data, but once the data is in, there's a lot that you can do with it very quickly. With that, I'll conclude this video and leave it at that.